So next up, I think we might as well get this arrow drawn up. It'll be nice and simple, considering we've just done paths already for drawing this arrow. We might as well now, while we're remembering, make this little arrow indicator. And then we might as well do some animation as well, get it moving up and down smoothly. This will get us ready for handling the actual real audio. So once we've done the arrow, we might want to tackle actually importing microphone audio and start getting things into the display. It's either that or the main grid. But for now, let's just take a look at handling this arrow. So if we go to the view, I think it is. Yep, the view, and we want the arrow. I think we're on it already. There we go. So we've just got a rectangle at the minute. This will be, let's just have a look at the background here so I can see where we're working. Right there, so that's nice and easy to see. So where's it gone? This canvas here is all the red. So we've got the full width, which is where we want to move this up and down. But this size is when you change the display. So we'll have to think about the position. But the main thing to do is let's get rid of this rectangle. So let's just replace that with a path for now. And in the path, we want to draw an arrow. So that should be fairly simple. If we remember, let's just fill it with white first. And the data, and remember this is stream data. We start with the M, and then we do X and Y position, and then draw what we like. So for an arrow over here, we'll start, say, 10 pixels across on the X and 0 on the Y. Then we'll draw a line, and we'll do that, say, 4 pixels in, so 6 back, and about 5 down. And then we'll draw another line. And this one will be 10, 10, so all the way down. And then you can see the arrow there. And then just for good measure, we'll just close it off with the Z. And we can hide that background now. We can see where we're going. And we currently have width of 20, so you could do width of 10 if you wanted to crush it in. And that will be the exact width of this arrow. So there's no extra, or you can make the arrow larger. Let's just take a look at the original Ulian loudness meter and see what that arrow is in terms of size, and we'll match. So you can see that arrow is actually much larger, so it probably is 20. So let's make our arrow much, much larger. So 30 over there. So in this case, we want to go 20 over instead of 10, and then 20, 20 to go down. And I'd say that's about where it is there. Now just move the center point down. Considering we're now 20, this wants to be 10 to stay centered. You can see this arrow is also slightly stretched. So we're probably on the width, which just means that the 0 and the 10 on the first parts probably want to move in. So maybe move it down 5 there and up to 15 there to make a pointy arrow. That's a little bit too much, so probably 17 and 3. And I'd say that's not far off. There's also padding here, which is equal to the other side, and at the minute we have none. So we could, on this, we remove the width. Does that auto size for us? No, it doesn't. So can we do on this canvas margin, and then let's have a look where left is. Left is the first one. Do a bit of padding there, and that now matches, I'd say, pretty damn close. So I'm happy with that. So that's the arrow we're dealing with. I could have zoomed in while we're doing this as well to see it here. Next, we want to now move. So in order to move this path, all we need to do, because we're in a canvas, you do canvas.top and set a position. So we set it to 5. You can see it moving. 50 moves down more. But these are absolute positions in terms of points on the screen. So it's not exactly, it's not 1 to 100 in percentage. So we'll have to deal with that fact after. But for now, let's just bind this to a property. So if we open up the view model, main view model, I didn't mean to move anything. There we go. Make another observable property. We will make this a double, and we'll call it volume % position. And then we'll just go back to the main view and bind this simply with binding volume. It should pop up, I think. Percent position. Not sure why it's not popping up, but it should, and it should find that. And to test it finds that, we could just set this to, say, 40. We might have to compile to get this to show. And there you can see it's now moved after we've compiled. If we go back and change this, we probably don't have to recompile now. Maybe just got to save. Oh yeah, so I guess the view model's compiled in order to show. But that shows that binding's working, and then this should update and move down. There you go. So we know the binding's working. And the next thing is to animate until we have real sound. Let's just animate this volume percent position when we open it, just do like a sine wave or something. So for that, we have two constructors, and we probably want an initialize function. So we'll do a private void initialize. And in here, we will then do initialize, just in case we ever want to run initialization code and it be handled by both design time and the default constructor. So in this, we just want a tick. We're just going to do a simple ticking timer and a basic value. We're going to do a sine wave tick. So we'll need for that just a temp timer. This is purely just temp code until we get the new audio stuff actually in and working. So we want a dispatch timer. And in this timer, we will want to set the interval to 60 seconds. So 60 frames per second in essence. That will be time span dot from seconds, and we want 60 seconds, but we want to run that every 60 times a second. So we'll want to divide 1 by 60. And that will give us an interval of effectively running this timer 60 times every second, if that makes sense. I'm going to start the timer here first, because I always forget to do that bit, and then go above, and now we can carry on with the code. And then every tick, so 60 times a second, we want to do, you'll have the sender and event args, which I'll just do shorthand like that for now. And there's our tick. So now what will happen once we spin up is we'll have something in here simply running every 60 seconds. For that, we can just test setting the volume percent position, just to increase it. And let's run this. Not sure why this is moaning that it can't find it. Perhaps something's glitched on the build. I might just have to clean and rebuild. And there you can see every 60 times a second it moves effectively 60 points per second, and that'll just disappear off the screen now. So we have movement happening, which is one thing we want. Now, instead of just increasing the volume position, we'll just increase this tick value, so we know how many times we've ticked overall, and it'll just keep counting up and counting up and counting up. We will want the input, which is going to go into the sine wave function. So input equals the tick for now, or let's slow it down a little bit. Let's say slow it down by 5, because it'll be running, I reckon, too fast for a sine wave. So slow down ticks. Then we can do a scale, because a sine wave will be from -1 to 1, and if we move -1 or 1 pixel, you're not going to see anything. So we want to move about, I don't know, say 100 points, 100 pixels on screen roughly, depending on your display resolution. So scale value we'll store in a variable for now. We'll just do scale equals 100, then we can play with that after. And then finally, we want to set the position now, and all we want to do is get the sine wave of the tick times by the scale. So fairly simple. Math.sine of the input, which is the tick slowed down by 5. You want a +1, because remember, sine waves go from -1 to +1, and basically you have a line. Let me just pull up an image of a sine wave so you know. You have 0 here, you have +1 here, and you have -1 here. So the sine wave is going to do this between -1 and 1. So if we add 1 to that, we're effectively going to run the sine wave on top of this curve and never go below 0. And then what we need to do from that is simply multiply that value by 100. So our wave will go from 0 to 100 in a sine wave. So we've added the 1 already. Now we just need times by scale. So it's pretty simple code. And that should now run. And that needs to be the actual volume thing, not the behind property. And I think that's all we need to see, at least, that we're going to have some kind of smooth animation. And you can see that's going way too quick for 60 frames a second. In fact, you can barely see anything happening. So, well, for one, divide it by a float so we don't lose the precision, which I don't think matters because we're integer. There you go, that's a bit smoother now. So we haven't lost the precision, and you can see you can actually see the motion moving. Out of curiosity, let's see if we do 120 frames a second, because this monitor is 120 frames a second. Although the video is only recording at 60, you're probably not going to see yourself, but I'll let you know if this is any smoother. Yeah, so that's running at 120 frames, I'd say. But there's not really much benefit there. So we'll change that back to 60, slow this down a bit more, go to 20 times, slow down instead of 5. And there you can go, you can see this kind of sine wave moving. So that's really it. Let's just put a comment here, temp code to move volume position. And I guess one other thing we could try and do, so instead of it being just random at the minute, just scaled, why don't we figure out that scale? In fact, it's as easy as having the scale be the actual value of the height of the canvas we are in. Now, this is similar to let's see if we can find it, the animated pop-ups code behind, where we get the size of things, basically. So where do we get the size? So on the render, we basically wait for, if we've not found desired size, not yet captured opacity, set the flag, blah, blah, blah. We do it all in here. And this is on render change. And we go through a timer before it then hits and decides to update the property. And we just get desired size of our own element here. So we could get the desired size minus the margin of the grid itself, the parent, every time we have a render potentially. And we'll pretty much say sizing timer. We'll do the same here. And we'll use this as a generic timer throughout all of it. And this is what timer? A system.threading timer. And this is a timeout timer to detect when auto sizing is finished firing. So timeout timer to detect when, yeah, effectively auto sizing when we're scaling. It's the same thing. When we drag it around, we want to update it once it stops moving for at least 100 milliseconds. So that will reset it. And then here we are creating a new size timer, which then dispatches an update thread. So we're pretty much taking this exact code, and we could make this into a function instead of a copy paste. And that's done in the constructor, not in here. So in the constructor of the main view, we will make the new timer, and we don't care. We are always going to accept this size. It's not the same as the animated pop-up. So every time we have a tick, we want to update the desired size, update animation. So in this case, we want to just say update sizes. And that can now be a generic method that we place anywhere. So we can chuck it in here. Private void update sizes. Something isn't closed here. There we go. And then over here, update desired size. Just literally sets the desired size to whatever the UI is at that moment in time. So at this point, we would do this, effectively get the main view model, and we could then from there get the we can set, even though my IntelliSense is completely broken for this entire session at the moment, we'll just take the volume percent position, and for now I'm just going to check if this whole system works and set it to 50. And that's not what we actually wanted to do, not the position. We wanted to set the volume container size. So volume container size we'll set to say 500. And then we just need to change this to be getting the size of the actual element in the main view, which is the container. So let's just see if that compiles and runs, and then in here now we set it to the size there, and that will happen every tick. So I think that should work. And you can see there that's clearly now worked. It set it to 500. So now we just need to set it to the actual canvas's size. And to do that, we can set the name, I guess, to volume container. And then in the code behind, we could store the actual property, which I'm not sure what it is at the minute. Private, it's going to be a canvas, isn't it? Canvas, which we don't really need to store that. We can say control, I'm sure, as long as it's got a height on. Let's go lower level in case it changes. And volume container. And then in the constructor, volume container equals get element, is it, or something? Oh, we're in a view model here, what am I doing? Not there, sorry. Placing this in the completely wrong place. Want to be in the main view. Code behind of the main view. There, and we've already done it here. So we've already done this exact thing. Main grid, I'm guessing main grid equals, yeah, fine control. So gather name controls, and volume container is a control of volume container, I think we called it. Cannot find volume container. So now we have the container, and that will be found straight away before update sizes ever lands. And this can now be, which will be called in the dispatch thread anyway, just the volume container dot desired size dot height, I'm guessing. I don't know if they just do height or desired size. We'll just try with desired size and height first. And that should only call whenever render's fired. So at any time the UI changes size. And that hasn't done anything or has failed because desired size doesn't work. Let's just put a breakpoint there a moment. Drag and let go. And you can see this does hit. And desired size, yes. You see desired size of the volume container is not working. Or is obviously probably working as expected, but that's not the one we want. So is it just height that we want? So our binding, our temporary binding possibly worked anyway. So you see there's no values here of the size. So it reckons the width is 20 and the height is 0. But you see you got bounds. So bounds has clearly got value. Bounds height. So let's use the bounds height in that case. But at least now we have the code working fully. So whenever you resize, this should also scale and scroll to the full height. Right, so that's clearly working in some way, but now our calculation's off on the size. So let's go take a look at our temporary code. And that will now be because we need to half that. And the reason is the sine wave is from -1 to 1, plus 1 is from 0 to 2. So we are half the size of the container. And that should now give us the ability to specify a size from, in this case, you can see 0. Well, now we want to make this so we can specify the value of 0 to 100. And that's fairly easy then, because we just rejig this calculation in a binding configuration. So we could change that to be a value converter on the UI, and we bind the position to something that's simply between 0 and 100. And then if we rescale this and let go, you can see it now scales with the exact scale of the actual range. We can also tweak this min and max. So you can see the min is pretty much bang on that 0 line just by more coincidence, but the overshoot here is slightly over. So we can fix that afterwards as well. But now we have an adjustable and visually scalable arrow that can show volume level. So I think it'd be quite cool to probably get the actual audio next and then have this bar really react to what we're saying and see this, this bar moving as we're talking. So that's it for this one, and I'll catch you in the next.